Okay, so the second problem here is add two numbers. Okay, so basically this is like a basic thing like which we learned so far, right? Uh, it's like adding the two numbers. So for example, here they have given the two numbers. Let's just for before going that it just looks like this, right? We need to add these two numbers and give back the result. Okay, so but now only the change here is instead of giving up the plain number, right? Instead of integer, the numbers are split across as a linked list. Okay, and in a linked list, in each element has a number value. Okay, and also one of the task is done here, like so meaning let's say that whenever we want to add any two numbers, right, basically we'll start the addition from this end, correct? Like even though we have a 342 465, we will do the sum from this side, right? So they have done the half of the task for us, like initially 243, and they have given the task for 243 and 465, like they've already reversed it and we don't have to take care of that part. Okay, now what is the logic here, like how to add up and give and return back the return back the final number, and also this should also be in the form of a linked list. Okay, so now the logic is simple here, like just like how we add any number, right? For example, 2 5, like 2 plus 5 is equal to 7, and we don't have a carry and we'll put it as 0, right? For time being, what we'll do is, to make our task easier, we'll assume that we'll carry, like when we start here, right, carry will be 0, right? So we'll be setting the carry to 0, and 2 plus 5 is 7. Okay, and there is no carry here, so 4 plus 6 is 10, 0, and carry will be 1, right? This is the same, exactly the same thing we'll be going to do here. So now, okay, now what we need to do is we'll have to go over the each of the element linked list and read the value and add the value and create a new linked list. This is what we are going to do here in this solution. Okay, and one thing is, before actually jumping onto the solution, one basic thing that we'll have to note down is, like initially when they give the um, L1, right, will be our reference, our pointer will be pointing to this location, right? L1, this will be the L2. Okay, and now as soon as we read this value, we should make sure that we update this pointer to the next one, so that we can get the value from here. So for example, what we'll do is, we are taking a sum, right? So what we'll have to do, we'll read the first value, 2 plus 5 is equal to 7. Now we'll have to read the next one, right? So we'll have to update the pointer to this. So how we do it, L1 is nothing but L1 is next, like as we know, right? In the linked list, in the linked list we have a data, and also we will be storing the address of the next node element, right? Next node element. So what we're going to say is, L1 is nothing but next, whichever the element that is present in the next. So L1 is equal to L1 dot next, so we'll be pointing to this node now. Okay, that is one thing we should be knowing before starting. So if we come back to this, um, yeah, so now what are we doing here? So basically, right, we'll have to check if the L1 currently, it's always here, right? L1 or L2 always will be there, correct? But in, if you see, there can be also condition like this, right? L1 can be empty and L3 will be there, right? If we, and we'll have to get into the loop, if at least one, like if any of one of them is present, we'll have to get inside the loop and or take care of it. Okay, and also let's say that if L1 is not there, L2 is not there, and also if there is one carry left, right, then also we'll have to take it consider, right? So for example, let's say 1 6. Okay, 1 6. For time being, let's say that, let's ignore these two numbers for now. Let's say that 6 plus 4, 6 plus 4, 6 plus 4 is 10, correct? Okay, one second, let me do it this way. Okay, let's consider 9. Okay, for time being, ignore these numbers. Okay, what I'm doing is 1 plus 9, 1 plus 9 is 10, 0 here. There is no L1 now, carry is left, like extra number is 1 here, and there is no L1, there is no L2, but there is a carry 1, right? We still need to consider it, correct? So that's why it is like this, like we'll have to check for carry also, and check if there is L1, if any one of the element exists in L1 or L2 exists. Okay, so now rest, now coming to this logic, we'll be checking for L1 first, and will be initially carry will be 0, right? We have declared it as 0. You know what is the start node and what is the result node. I've just kept it as none for now. Okay, and here, yeah, carry will be 0, like initially when we start, right, carry will be 0. We'll be reading the value from L1, we'll be reading the value from L1, that is 2, and then here we'll be reading the value from L2, we'll be adding to the same carry, and we'll be getting the final result here basically. Correct. And also, as I said, we need to update a reference to the new node, whichever that is present in the next to the current node, right, will be pointing to that. Okay, L1 is equal to L1 dot next, L2 is equal to L2 dot next. And then let's say that now, right, like we'll have to find the carry, and we'll have to find the what is the number that is going inside this node, right? Like, so as we keep on adding, like we need to, we'll store one number, right, 7, and whatever the number that is in the left, we'll have to keep that as a carry. So that's what is being done here. We'll be taking the remainder. So if it is a 17, right, so we'll be picking the 7 here, we'll be picking the 7 here, and carry will be the 1. So this is the logic here. And here, for the first time when we enter the loop, we don't have any start node, right? So I said I'm checking here that if we have a start node or not. Okay, if we don't have a start node, create a list node, like create a one linked list node and add the number which we are supposed to add. This is the number 7. Okay, and now will be this will be the result, right? Let's say that if there is only one number, this will be the final result. Correct. So I'm just putting it as a result is equal to start node. Okay, and now next thing is, we'll come again in the next iteration, and we'll do the same thing. We'll read the value from here, we'll read the value from here, and find the right number, and also find the carry. We'll find the carry. And now we already have a start node. It's not none, right? It's not none anymore. So what we'll be doing here is actually already pointing to the start node, and we'll be saying that whichever the we'll be adding, creating this node and adding as 0 here. Okay, we'll be adding it as 0, and we'll say that start node will point to the new node, which is 0. Okay, and yeah, that is it. Like, we got a 0, we created a 7 first, and we created a 0 first, and we have pointed 7 to 0. And then we'll have to update our reference, so that we'll be pointing to this now, so that we can go to the next value, right? We can point to the next tab, we can add a new value to the old linked list, right? So we'll be updating our reference here, so it will be going on a loop now. So if there is a carry left, or if there is any number to add in L1 or L2, right, we'll be just reading it, appending it to the carry, and then finding out the right number and carry, and just creating a new node and updating the references, like creating a list of it. And yeah, these are the test cases that I've passed already, and submission wise, this is the result. Yeah, thank you.